Welcome back to LocalM Tuts. I'm Nilay Parikh. This is lesson 7 of the 16, A2A client fundamentals. Last time we wrapped up our agent as a fully discoverable A2A server with agent card and HTTP endpoints. If you're watching this as a standalone video, please find the link of the full playlist in the description section below. Here is what you're gonna find the code for this lesson, the GitHub repository and interactive course page. In the description section, clone the repo, open the lesson folder, and follow along. The client has 3 important steps: resolve the agent card to discover the capabilities, send the blocking request to get the full response, and send a streaming request to get real-time SSE updates. Blocking is simple: 1 request, 1 response. Streaming gives you real-time progress, status update as the agent works, and the artifact chunks as they are generated. Both use same JSON-RPC protocol. Let's see this in action. First, make sure A2A server from lesson 6 is running on pod 10,001, and then we will run the client script. It discover the agent card, send the blocking request, receive the response, and then some streaming. Watch SSE event flow in real time. We left the server running from our last example, and it is listening on 10,001. So now let's see how it works on our client side. We also have an interactive page. If you're not in access with computer, you can obviously use this on mobile phone. It's a screen friendly, and it got a lot of other information to read with the question and answers. Very helpful in the interviews if you're preparing for any artificial intelligence engineer roles. Now, let's get started with our client. So this is simple notebook with covering most of the important client fundamentals, and in this notebook we will inspect the multiple skill, send the blocking request, handle the multi-turn conversation, stream the response with A2A client, send message and streaming, artifacts with text part, data part. We'll also try to cancel the task and see what happened, exchange the structured data, and handle the errors gracefully. You can see what features we are exercising here. There is a decent read in this notebook. I would strongly recommend you to take a time, give a read for a couple of times. It might be a difficult concept if you are not familiar with the abstract programming. So let's start installing the dependencies if we need to. All dependencies there, just running a simple class, which, right, so did I run this? And let me double check, be safe, and then discover the agent. Then you discover the agent, and there we go. Remember from a last skills, policy QA, custom claims filing, and policy summary. It's all coming from server. So we haven't implemented an agent class here, nor we have implemented an agent server. We are purely connecting to localhost 10,001, and you can see based on agent card we are resolving all of this, and we are getting skills and all the information that we need, and our LLMs to decide what skills it need to execute at what time. So let's see if we are ready with helper. Very good, client is ready. Now we're just gonna build a very simple request. So these are just a builder methods. Let's define them. Here I think there are more methods. Let's define them, and then we will start with the blocking call. It's a simple policy queuing. So in this particular example, it is running via the server. So if I open the server here, you can see we are connecting. So we connected the agent card first, and now we are connecting to the HTTP one request, which is the JSON RPC request coming from this client. Well done. So I think completed the build request. We just completed the block task completed. Answer. So what we have asked, what is the annual deductible? So we got all the same answers from the client. So if you have seen the lesson 5, this was the same answer coming. And now we are getting the same agent executed using the server. And this is the beauty. You can actually compare all the question and answer from agent and client. They will always match. And now we're going to do the test multiple question and answer. Very good. It's moving quickly. Wonderful. We got all the answers and they're absolutely correct. Now, multi-term conversation. It's the same multi-term conversation that we have demonstrated in the A2A agent, but now we will be calling using the A2A protocol via the server method. So let's turn the partial claim and we will send missing information. So it should come back with the state input required. And then we will provide the missing details. So it has come back and said, task input required state, please provide the date of service, amount and description. So I'm going to provide them here. Service on this and description. And by the way, I'm not passing the structured data. I'm passing semantical data. And it will translate into structured data and process. This is why self-discoverable agent with a true agentic capability are facilitated. And this is why it particularly solved the N-square problem. Because if you, let's say, if you're building an insurance company claim portal or a claim submission portal, it's one of a nightmare to handle the number of the fields that required, number of the processes that required, and all of this can actually become very simple if the correct abstract process has been followed and we actually build the agentic AI. And that reduced the N-square problem into the N problem. And O(n) square is exponential cost against the linear business value compared to O(n), which is the linear cost against the linear business value. And that's why when the business scale, the O(n) always give far more competitive edge over the O(n) square. So well, we completed the task, the claim process has been completed, and all sort of stuff that expected is coming back. And it explained what multi-flow summary should look like, structured data policy. So we're going to pass simple information and say, give me summary of my policy. And this is the same example we also run during the A2A agent. There you go. It's perfect. Streaming response, same way. Please read the sequence diagram. It's very interesting and important to understand how the SSE stream works. Generally, SSE is not they are not dealing with SSE when it comes to backend simple microservice architecture or service-oriented architecture. But SSEs are very important when it comes to agentic AI and something need to be mastered for sure. So all I'm gonna do is I'm gonna stream my question and answer and see, look, it is actually working in progress. And soon as my question and answer is been delivered back from agent to this particular client, it will print it. So it's continuously running. Instead of blocking the call, it is progressing as it receives the artifacts and the process and the updates. There we go. We got both of them. Very good. Now we are doing the stream policy summary. It's going to work like same, so I'm going to skip it, but this is how the response going to look like. The task cancellation, so we'll fire the task and then we'll cancel it. There we go. We fire the task. First of all, we got the response, then we cancel it. So if you see here, we build a payload, we create a request. I want a file medical claim, send, and then immediately we send the cancellation request, cancellation as well. So here, cancel payload, and then we go ahead with And we got this whole IDs, then text, everything that we discuss, return. Task polling. So it will constantly give us what is happening with a task. There's nothing there. And error handling. So here we expect the error, which is not the error that is not the error, technical error, but as I said, that there will be out of the scope questions, like what medication are excluded. That information is not available in the context. So we anticipate that policy document does not explicitly specify the requirement. So this is what it called safe queries and guardrailing. And let's see how it works. So error handling. And obviously we do handle errors such as like connection, etc. So policy does not specifically, however, it does not. Perfect. Get the non-existence task. So here you can see we are trying to get some of the tasks that doesn't exist, we haven't created, and we are getting the response graceful failure. Test the invalid method. This method doesn't exist, and we get a very reasonable message. And the experiment. So we are going to file the response. Here we go. We are filing the response, and response has been filed. And now we want to close the client. So let's close the client. And there we go. And we covered everything that we anticipated. So let's see how server works. So you can see here, we made a lot of good requests to server, and we practically achieve everything that we need, and including the request failure that we force the method not found. So that's a very detailed understanding of generic capabilities, what A2A client can do. So this time we went from client to server, and then we invoked the agent via the executor, so abstract executor. And that proves how A2A actually deliver end-to-end agent infrastructure and how it communicate across the multiple layer. Now you have the complete server client loop, agent card discovery, blocking requests, streaming request, error handling. The client pattern is reusable in every integration session. Thanks for watching this lesson on LocalM Tuts. In the next session, we will integrate Microsoft Agent Framework. So from next lessons, we will start exploring different frameworks available to us and how they integrate with the A2A agents. Building an orchestrator that route the tasks to remote A2A agents, and you can find the next video in the A2A protocol course playlist. Link available in the description. I see you there.